Hello, today we're going to look at doing a small coding kata. It's going to be done in JavaScript and it's going to be the bowling kata. So I'm going to base today's video on the description from Coding Dojo, and I'll leave a link to this page in the description below. Let's take a quick look at the problem. So we need to create a program which, given a valid sequence of rolls for a game of 10-pin bowling, produces a total score for the game. So we're always going to be given the correct number of rolls for a valid game, and we only need to worry about calculating the end score, not intermediary scores for each frame. Before you start coding this kata, you're going to have a bit of an understanding of how scoring works in 10-pin bowling. So each game consists of 10 frames. In each frame, the bowler has up to 2 tries to knock down all of the pins. If in 2 rolls the player doesn't manage to knock down all of the pins, their score for that frame is just the number of pins that they did manage to knock down. If in 2 tries they manage to knock down all the pins, the frame is called a spare, and then the score for the frame is the 10 pins that they managed to knock down, plus a bonus score from their next roll. If on your first roll of a frame you manage to knock down all of the pins, that is a strike. You get 10 points for knocking down all the pins, and you get bonus points from the next 2 rolls. If you get a spare or a strike on the last frame, to calculate your bonus score from getting that spare or a strike, you take either an additional 1 or 2 rolls. These bonus throws are taken as part of the same turn, so you can't get additional strikes or spares off of them. The total game score is then the total from all of the frames. So in this video, to code up the kata, I'm going to be using Visual Studio's Code and also NPM. So if you don't have VS Code, you can get that from code.visualstudios.com. And if you don't have NPM installed in your terminal, it comes as part of node.js. So you can download that from nodejs.org. Finally, if you don't want to try and install VS Code or Node.js, and you're just interested in writing a bit of code, this kata is also on Code Wars, and I'll also include the links to all of these things in the description below. Okay, with that being said, let's get coding. First, let's open up VS Code. Then we can go to the Explorer tab, and we'll click Open Folder, and I'm just going to create a new folder on my desktop for putting the code in. So we'll just call that Bowling Kata, and I'll click Open. So that's created a new folder on my desktop, and it's also pointing VS Code at that folder as a workspace. We can then create new files and folders in that folder using the Explorer tab. So now we can full screen VS Code. I'm going to open up a terminal window as well. And then within here, we're going to initialize an npm project. First, let's check that we've got npm installed. So you can do npm-v, and it should print out a version number. If this doesn't work for you, you probably need to install npm, and that's where you need to go to nodejs.org and install node. We'll do npm init, and then we'll just use all defaults for these. That creates us a package.json, which gives some basic metadata for our project. Next, so that we can write unit tests in our project, we're going to install a couple of dependencies called mocha and chai. So back in our terminal, we'll run npm install -D mocha. As you can see, that's added mocha as a dev dependency to our package.json. This also brings in all the code for mocha and places it in node_modules for us. We'll do similar for chai. These are the 2 dependencies I'm going to use to write unit tests for our code. I'll also change the test script to be mocha, and I'll also put in here a type of our project. I'll set that to module. So setting the type to module will allow me to use JavaScript modules, which is the export and import syntax. Next, I'm going to create a source folder, and I'm also going to create a test folder. In my source folder, I'm going to create a file called bowling.js. And in here, I'm going to create a calculate score function. It's going to take an array as an argument. And it's going to return a score at the end. And I'm then going to export that function and save the file. Within the test folder, I'm going to create a new file called bowling.test.js. This is where I'm going to write our unit tests. At the top, I'm going to import chai by writing in import chai from chai. Because we installed it as a dev dependency, it should be available to us when we run our tests. After that, I'm going to assign assert to equal chai.assert. This will be useful when we're writing our unit tests. I'm also going to import our calculate score function from bowling.js. So we'll do import calc score, and it's also filled it in there, but from /source/bowling. So we'll save that. And now we can look at writing our first unit test. So we need to write a describe function and give it a descriptive name. So we'll put in scoring bowling, and then after that, inside of the function, we can start writing some unit tests. So for our first unit test, we just want to think of the simplest possible scenario we can test. And the best thing I can think of is maybe us throwing 20 gutter balls in a row. So if I go and play a game of bowling, and every single time I throw a ball, it ends up in the gutter and I knock down 0 pins, then at the end of the game, my score should be 0. Let's write a test and check that our function can calculate that. So we'll write a it function. In there, the first argument will be a description of our test. So all gutter balls goes to 0. We'll describe what our test is going to test. And then in a function after that, we can write our assertion. So if we look at our calculate score function, we're going to pass all the rolls that I do as an array into it. So if I do 20 gutter balls in a row, that should be an array filled with 20 zeros. So I'm going to create a new constant called rolls, and we're going to say that equals to an array with 20 zeros in it. So let's say the first frame is a double gutter ball, and then every frame after that is also gutter balls. So we could write it out like this. This makes it very clear that we've kind of got our 10 frames, and in each frame, each roll, I knock down 0 pins. We're then going to take our array of rolls and pass that into our calculate score function. And that's going to give us back the result from our function. And then we're going to put in what we expect it to be as another constant. And finally, we can check that our actual result matches our expected result using an assertion. So to do that, we'll do assert.equal. And we'll pass in our result and our expected. Let's save that. And then to run the tests, we should just be able to run npm test. I think that what's wrong there is that I need to set a JS there. Run that again now, and we see that we've actually got our test running, but it's currently failing. We can see that our function is currently returning -1, and we expect it to return 0. So the next thing we want to do now is go to our code and make it pass our test. At the moment, we can simply do that by returning 0. Let's save, and then we can rerun our test. And we can now see that we have 1 passing test and no failing tests. It might seem a little bit silly for us to write a test and allow it to pass just by returning 0. But if we take the ideas of test-driven development, what we want to do is gradually build up our functionality by writing more and more tests and adding more functionality only as we've written tests that can test that functionality. So we've essentially covered the first 2 parts of that at the moment. We've written a failing test, we've then made the test pass, and now we need to do any refactoring that we want to do. One thing that we could tidy up is this creation of an array. we could do that on one line in a way that would still be easy to read and understand from a testing point of view. So we can change that to array of 20, fill it all with zeros. Save that and rerun, we should get the same result. So now we move on to our next test. So I'm going to take the setup that I already have. I'm just going to modify it slightly to say that if we roll all singles, so every time I roll a ball, I knock down a single pin, I'd expect to have a score of 20. So now our rolls is going to be an array filled with ones, and I also need to change expected to be 20. Let's save that and run the tests again. And we can now see that I have one passing test and one failing test. So my first test is still passing and my second test is now failing. So again, with PDD, we want to write a failing test, then we need to update our function to make the test pass, and then we'll refactor after. So at the moment, the easiest thing that we could do to make our tests pass would be to sum up all of the numbers in our array. So to do that, we could write a for loop that loops through rolls. And we can start out with a score of 0, and then we can increment the score for each roll, and finally return the score. We save that, let's see if that passes our tests. Okay, great, so that's passed both of our tests now. So let's think of what test we should write next. That will force us to introduce even more functionality to our calculate score. So we know that sometimes a player can get a spare. So if in a frame, using 2 throws, they knock down all 10 pins, then we need to add a bonus from the next throw to their score. So let's write a test that will allow us to implement that. So let's write a test for a spare. So there we've got kind of 10 frames. So let's say in the first frame, they knock down 5 and they knock down 5 on the second throw. This is therefore going to be a spare. And then on the next frame, let's say they knock down 2 with their first throw and another 3 with their second. And after that, they throw all gutter balls. Let's have a think through what their score would be. So they would get 10 points from knocking down the 10 pins in the first frame. They would also then get an additional 2 bonus points. So they would get 12 from their first frame, and then they would get the additional 5 from their second frame. So 12 and 5 is going to be 17, and that's what we should expect them to get from this set of rolls. Let's run our test, and again we can see that we now have one failing test, and we're going to have to go and implement the logic for calculating a spare in our bowling.js. So now instead of looping through all the rolls, I think we need to introduce the concept of having 10 different frames and having a first roll and a second roll in each frame. So let's update our for loop to loop through 10 frames rather than all the indexes in rolls. So it's going to be let frame equals 0, roll frame is less than 10, frame plus plus. So this for loop will loop through 10 times. In each frame, we then need to get the 2 rolls for that frame. So in the first frame, that will be the first and second elements in the array. In the second frame, the third and fourth, and so on, until we get all of our 20 different rolls being mapped to our frames. What we'll notice is that the first roll in each frame is going to be equal to our frame multiplied by 2. So we'll have a frame index, and we'll have that equal to frame times 2. After that, we can get our first roll for the frame, for our second roll as well, but that's going to be the next index to it. We'll add both the first roll and the second roll to our score, and then we'll also check if first roll and second roll are equal to 10. We know that the player will have scored a spare. And at that point, we need to add to the score a bonus of whatever the next roll is going to have been. In our case, that's going to be roles frame index plus 2. That will give us the one after the role that they took after the second role. So let's save that. And let's see if that passes all our tests. Okay, great. So we've implemented the logic for spares there. So we might also want to test to check that our spare logic also works if it's in the 10th frame as well. So I've set up a test to check for throwing a spare in the final frame. So we throw a 7 then a 3 in the 10th frame. We will get a bonus throw. If we throw an 8 on that throw, we should get a total score of 18. So it takes the 7 and the 3 from the final frame, and then this last bonus throw just gets added as a bonus. Let's save that and see if this test passes. And we can see that this test actually already passes with the logic we've already written. So now we have normal frames covered where we don't knock down all the pins, and we also have spares covered. We finally need to calculate what we do for strikes. So I'll take this test that I've written for a spare and modify it slightly to cover a strike. So when a player gets a strike, they will get a bonus from the next 2 throws. So let's just say that their first throw is a 10 in their first frame. And then in their second frame, they score a 2 on their first throw and a 3 on their second. And then after that, they all get gutter balls. We should be able to calculate what the final score should be. So they should get a 10 from the first frame, plus the bonus from the 2 and the 3. So 15 from the first frame, and then the 5 from the second frame as well. So their total score should be 20. Now obviously this complicates things a little bit because we no longer have got 20 roles. So we're going to have to deal with that somehow. But let's just go and run our test and see what we get. So we ended up with not a number. The code that we currently have is expecting at least 20 roles to be there. And now that we've actually introduced strikes, some of our frames won't have 2 roles in them, and therefore we can actually have a game with significantly fewer roles than 20. In fact, if you score strikes on your first 9 frames and then a normal frame at the end, you would only have 11 roles in total. So what we're going to need to do is maybe set our frame index up here and increment it by either 1 or 2 based on the result of the frame, whether or not you've got a strike or not. So we'll start the frame index at 0. After we've got the first roll, we need to write some branching logic based on if you've scored a strike or not. So if your first roll of a frame equals 10, then you've got a strike. We need to increase the score by 10 plus the results of your next 2 throws. So that's going to be 10 plus, to get the next 2 scores, we'll do frame index plus 1 plus the rolls of the one after that as well. And after that, doing that, we'll also increment the frame index by just 1. If you didn't get a strike, we'll have an else block. So we'll just remove the code that we previously had. That will then get the second roll. It'll then add the score of the first roll and second roll. It'll check if you've got a spare. And if you've got a spare, it'll add the bonus. And the last thing we need to do is increment the frame index by 2 in this case. So in the case that we've got a strike, we move our frame index on by 1. And in the case that we don't get a strike, we move our frame index on by 2. Let's save that and see if this logic passes our tests. Okay, that's passing, which is great. So we might now want to add an additional test just to check that our strike logic works for a strike in the final frame as well. So we'll change the final frame to be a strike. So if you got a 10 as your first roll in your final frame, you would then get an additional 2 throws. So let's say you got another strike straight after that. Again, from the rules that we had before, you can't keep chaining strikes in the final frame. The last 2 throws in the final frame, if you've got a strike, are just to calculate your bonus. So we'll add a 1 in as well. So the result for this should be 21. 10 from the strike, and then the results of your 2 bonus throws. Let's just run that test, and that's passing. Let's change our title as well. So we can change it to strike in the final frame. Okay, so we now have our scoring bowling, and we've got all of these tests passing. Our logic is passing for all our boundary cases at the moment. There's a few more tests we might want to throw in there as well, just to make sure. So let's test for if someone has a maximum score in bowling. So we'll take the test for all gutter balls, and we'll replace it with all strikes. And the maximum score you should be able to get in bowling is 300. In this case, we'll have 12 throws, all with a 10. So this reflects in every frame you getting a strike, and in the final frame you having 2 bonus throws, and you scoring 10 in each of those. Let's run our tests and check that that's working. And I think we'll leave things there. So we've got our set of unit tests for our bowl and kata. Our tests cover all of the main scenarios we need to consider. Okay, so now that we've got all of our tests written and we've got a code that is working, the last thing we might want to do is consider how we could actually clean up this code any further. There's a few options that you could do. So for example, rather than having this frame index, which is incremented by 1 or by 2, depending on if it's a strike or a spare, we could instead make a copy of the roles array and use shift to kind of remove the first element every time we're asking for a role. And that would remove the need for us to keep track of our frame index. There's lots of other ways people have implemented the bowling game Kata over the years as well, using object-oriented programming approaches, but for now I'm happy with this as a implementation. Okay, that's all our code implemented. So again, I'll include the links to the Kata in the description below, as well as the links to VS Code, Node.js, and the Code Wars Kata as well. I'll also leave a link to my code on GitHub. Okay, thanks for watching. I hope you've enjoyed it. I hope you've found it informative. If you have, leave a like or a comment. It's much appreciated. Have a good day.